on April 20th, 2023. The most powerful rocket ever built thundered into the Texas sky. For millions watching around the world, it was the beginning of a new era in space exploration. But long before Starship ever reached the launch pad, another engineering revolution had already begun, just a few miles away. Inside Starbase, engineers were building something just as important as the rocket itself, a manufacturing facility designed to produce Starship and Super Heavy at a scale the aerospace industry had never attempted before. The goal wasn't simply to build bigger rockets, it was to completely change how rockets are manufactured, assembled, tested, and prepared for flight. Because if humanity hopes to return to the moon and one day reach Mars, building one rocket at a time simply isn't enough. The future of spaceflight would begin inside a factory. Building a rocket factory of this scale couldn't happen just anywhere. SpaceX needed more than a large piece of land. It needed a place where giant rockets could be manufactured, tested, and launched from the same location. After years of development, the company transformed Boca Chica on the southern coast of Texas into what is now known as Starbase. The remote location offered several critical advantages. There was enough space to build massive production buildings, conduct engine testing, and expand the facility as Starship continued to evolve. Most importantly, the factory sits only a short distance from the launch site. Instead of transporting rocket stages across the country, completed vehicles can move directly from the production area to final testing and launch preparations. That saves time, reduces risk, and allows engineers to improve designs much faster than traditional aerospace programs. But choosing the location was only the beginning. The next challenge was far more difficult. How do you design a factory capable of building the largest rocket system ever created while keeping production moving every single day? Designing Star Factory was unlike building a traditional aerospace factory. Starship is nearly 400 feet, 121 meters tall when fully stacked. Far larger than most rockets built before it. That meant the factory itself had to be designed around the size of the vehicle. Inside the production buildings, massive overhead cranes lift rocket sections weighing many tons with millimeter-level precision. Large stainless steel rings arrive at dedicated assembly stations, where automated welding systems permanently join them into the rocket's main structure. Every production area follows a carefully planned sequence. Raw materials enter from one end, completed sections move through inspection, then continue to the next stage without unnecessary delays. Instead of treating each rocket like a one-time project, SpaceX designed Star Factory for continuous production, allowing multiple Starship vehicles and Super Heavy boosters to be built at the same time. But building the factory was only the first challenge. The real engineering began when ordinary sheets of stainless steel had to become the largest rocket ever built. Every Starship begins with one essential material: stainless steel. Unlike many modern rockets that rely on lightweight carbon fiber composites, SpaceX chose stainless steel because it is stronger at extremely low temperatures, more resistant to heat, and significantly less expensive to manufacture. Inside Star Factory, massive steel coils are delivered to the production floor, where they are cut, rolled, and formed into giant cylindrical rings. These rings become the basic building blocks of Starship. Using advanced automated welding systems, engineers permanently join dozens of rings together to create the rocket's enormous tanks and main body. Every weld is carefully inspected using precision measurement tools, because even the smallest imperfection could affect the rocket's structural integrity. Once the primary structure is complete, engineers begin installing internal tank domes, structural reinforcements, plumbing, and the complex systems that will eventually carry thousands of tons of super-cooled liquid methane and liquid oxygen. Piece by piece, the world's most powerful rocket slowly takes shape. But without its engines, this giant stainless steel structure would never leave the ground. A rocket is only as capable as the engines that power it. For Starship, those engines are called Raptor, Unlike conventional rocket engines, Raptor uses liquid methane and liquid oxygen, along with a full-flow staged combustion cycle, one of the most advanced engine cycles ever developed for an operational rocket. Each engine is built from hundreds of precision-engineered components. The turbopumps, combustion chamber, injectors, valves, and fuel lines are manufactured separately before being assembled into a single engine. Every component must meet extremely tight engineering tolerances. Even the smallest defect could affect engine performance under the intense temperatures and pressures experienced during launch. Once assembly is complete, the engines undergo detailed inspections before being installed on Starship and the Super Heavy booster. Together, these engines generate enough thrust to lift the largest rocket ever built off the ground. But before any Starship is cleared for flight, engineers must prove that every system can survive one final test. Building Starship is only half the challenge. Before a rocket is ever approved for flight, it must prove that every system performs exactly as engineers expect. At Starbase, each completed vehicle goes through a series of rigorous inspections and tests. The propellant tanks are pressurized to verify their structural strength. Electrical systems are checked, flight computers are tested, and thousands of sensors are inspected to ensure they are communicating correctly. The Raptor engines are then put through static fire tests, where they are securely mounted and ignited while remaining fixed to the ground. During these tests, engineers monitor thrust, fuel flow, pressure, temperature, and vibration in real time. Every second of data is carefully analyzed. Only after the rocket successfully passes these critical tests is it cleared to leave the production site and move toward the launch pad. But Star Factory wasn't built just to launch one successful rocket. It was built to change the future of spaceflight forever. When a Starship finally leaves Star Factory, it isn't the end of the manufacturing process. It's the beginning of its mission. Just a short distance away, the vehicle arrives at the launch site, where engineers complete the final integration, perform one last series of checks, and prepare the rocket for launch. This close connection between manufacturing, testing, and launch operations is one of Starbase's greatest engineering advantages. Instead of shipping rockets across the country, everything happens within a single integrated complex. That saves time, reduces costs, and allows new improvements to move from the factory floor to the launch pad much faster. But Star Factory wasn't built simply to support today's launches. It was designed for a future where rockets can be built rapidly, reused repeatedly, and eventually carry humans back to the moon and onward to Mars. Inside these buildings, every weld, every engine, and every inspection brings that future one step closer. Because the next chapter of space exploration doesn't begin in space. It begins inside the factory where every rocket is built.